Hi all, and welcome to my new video related to Bitcoin education. This is the 13th video related to explaining the blockchain, and we will discuss about step 9, the longest chain rule to reach consensus. This presentation is for educational purpose only and is not a financial advice. As always, these are the two books I take as reference. I strongly recommend you to read both of them if you want to know more and more related to how the blockchain is working. As you can see here, we are the 13th video. It remain only three, including this. The last two will be related to the last two problems that Satoshi Nakamoto solved in order to have a fully decentralized system. And then will be a conclusion. Let's start with the summary. So at this point, we have transaction bundled in blocks, and bookkeepers agree on the order of blocks that are propagating around the network. We have therefore eliminated the role of the third party in creating accounts, in maintaining and ordering the list of transactions. Furthermore, we have miners who are creating the blocks that contain the transactions. The miners are incentivized via block rewards and transactions fees. We have also introduced the difficulty adjustment that makes sure that the programmed scarcity is kept, despite the advances in technology and the increase of the hash power. Furthermore, we have a setup blockchain to order the blocks. There is still chance then, but there is still chance that blocks are created by different miners at the same time due to the random process of hashing. If a bookkeeper receives two valid blocks from two different miners and they both reference the hash of the previous block, how does the bookkeeper knows which one to use and which one to throw away? How does the network come to the consensus about which block to use? And if a miner receives two valid but competing blocks, how do they know which block to build next to? The solution is called the longest chain rule. But before discussing about this, let's discuss about how transactions are added and verified. I wanted to deep dive on this, but only now because now we have all the tools in order to understand it in deep. And you don't have to remember everything, but it's important that you grasp and understand the big overview behind it. In order to ensure that only valid transactions are added to the system, all nodes of the system are allowed to act also as supervisor of their peers and reward them for adding valid transactions and for finding errors in the work of others. The individual rules and procedures that can be traced back to the following building blocks are five: validation rules, um, rewards, punishment, competition, and peer control. Let's discuss about each of them. First one, the ultimate goal of the blockchain algorithm is to ensure that blockchain data structure contain only valid blocks, which in turn consist of valid transaction data and valid block headers. The rules for transaction data define which data are required for describing a transaction. For example, correctness, semantic, and authorization. Already see in a previous lesson. And the rule of the rule for block headers focus on the semantic correctness of the block headers. They are concerned with the way the information is added to the blockchain. A central element is the verification of the proof of work. Only blocks whose headers contains a correct solution of its individual hash puzzle are processed further. That's the first. Second is reward. Creating valid blocks costs energy, time, and money because it requires solving the computationally expensive hash puzzle that is unique for every block. The blockchain algorithm defines, in fact, how nodes that submit blocks are rewarded. From a more abstract point of view, it can be stated that the reward is the compensation for all burdens related to achieve and maintain the integrity of the network is the second. The third is punishment. The blockchain needs also a way to punish peers for counteracting integrity of the system. Typical measures of punishment are reclaiming the rewards for blocks that were accepted in the past but were identified as invalid or useless later on. The fourth rule is competition. The best way to achieve a high quality of work while reducing cost is to establish a competition regards on well-defined with on well-defined criteria. There are two types of competition, speed and quality competition. The speed competition is based on hash puzzle, with the central element of creating a valid block is creating the proof of work, which means solving the unit hash puzzle of the new block. Quality competition focuses instead on the correctness of the submitted block, with the nodes validating the new block based on the validation rules and transaction data and block headers. The last rule is peer control. It is also very important. With the absence of a central authority or a central point of control, the blockchain algorithm makes all nodes of the system the supervisor of all other nodes. The nodes are both workers and supervisors at the same time because they verify the transactions and create new blocks while receiving, reviewing, and validating the blocks created by other nodes as well. So let's now discuss about how it works. But the procedures that governs how nodes deal with new transaction data and block they receive from their pairs consist on several rules. There are 13. You don't need to learn each of them, but it's important you have a thought on each of them and you grasp the highlight and the overview, as I said. So let's just name all of them. First, new transaction data as well as new blocks are forwarded to all nodes in a gossip fashion. Each node collects new transaction in an inbox and select them for processing. Each node processes new blocks immediately with the highest priority. As soon as you have transaction, you start to process new blocks. Each node processes new transaction data by validating item for authorization and formal and semantic correctness. Each node collects only valid transaction data into a Merkle tree and starts creating a new block by solving its hash puzzle. As soon as a node finishes the hash puzzle, it sends the newly created block to all other nodes. Seventh, each node processes new blocks by verifying the solution of its hash puzzle and by verifying all its containing transaction data for formal correctness, semantic correctness, and authorization, as we discussed earlier. Each node or in previous lectures, each node adds valid blocks to its own copy of the blockchain data structure. If a newly arrived block has been identified as invalid, it will be discarded and the nodes continue with processing transaction data or finishing the hash puzzle of a new block. If a newly arrived block has been identified as valid, the node removes those transactions that are contained in a new block from its inbox and starts with processing transaction data and the creation of a new block. If a block that was added of the block to the blockchain data structure is identified as invalid or useless later on, that block as well as all its subsequent block will be removed from the blockchain data structure and their transaction will be added to the inbox to be processed again. The node whose blocks was accepted will receive the fees for all transactions containing the block as reward. And if a block is removed from the blockchain data structures, then the reward for adding it is withdrawn from the node that initially received it. The most important weapon of the blockchain against dishonest behavior is the power of the honest majority and the effect of rewards and punishment. And now let's discuss about the highlights of the longest chain rule. I want to discuss about the verification of transaction, which are the rule now in the deep, because now I think it's the best moment that you can understand which kind of rules the algorithm has. But now let's discuss the longest chain rule. So we have more, the problem was we have more valid blocks creating at the same time. How do the bookkeeper recognize the valid one? We have the protocol called the longest chain rule. So the longest chain is the chain that should be considered the chain of record. And the block that is discarded is called an orphan. The transaction included in the orphan block and not in the valid block will be considered unconfirmed transaction and included in the next blocks. Let's look at an example. If we have a situation that after block B4, 5, 6, there are two valid blocks, C7, 8, 9 and D1, 4, 5. How node, my node can say which is the right one. After we have to wait few minutes because after new blocks are created and E167 is attached to C789, the network will choose C789 as valid and will disregard D145 as orphan because the node with contain the blockchain that contains C789 is longer than the one that contains D145. All the transactions included in D145 and not in C789 will be considered unconfirmed and will be included in one of the next blocks. This is how it works, the longest chain and the protocol, the longest chain and longest chain rule. And this is the end of this video. We have other two videos. One is about the rule to wait about 6 blocks and then the conclusion. I hope you enjoyed and see you in one of the next video. Bye.